Welcome everyone to our webinar, which is titled Implementing Software Quality Assurance Best Practices. My name is Ben Horompoli and I'm going to be hosting today's webinar. I'm a pre-sales colleague here at Intland. Let me walk you through the agenda today. So first I'm going to introduce our company, Intland Software. And then these are the main points I'm going to be talking about. They overlap a little bit, so this isn't the exact sequence of the agenda, but this is what I'm going to be talking about: the role and benefits of software quality assurance, implementing adequate QA across the lifecycle, the most valuable QA methods, processes, and techniques, and then that will be followed by a live demonstration of our tool, codeBeamer ALM. Few words about today's webinar before I get started with everything else. At the end, I will be holding a Q&A session, so you can ask your questions if you have any, and a recording will be sent to you, and will also be available on this website here, on our website. Also, feel free to check out our upcoming webinars and events. Next week, I'm going to be talking about ALM business intelligence with visual data analytics, so dashboards and reporting, which is going to be a new feature coming out probably next week with our big 8.0 release. Okay. Few words about our software, our company. We were founded in 1998, and our headquarters is here in Stuttgart, Germany. We have resellers in UK, China, Korea, Taiwan, France, and Italy, an office in Silicon Valley, California, USA, and our rollout partners are Lufthansa Industry Solutions. And we're the sole vendors and developers of the codeBeamer ALM solution. This is a list of our biggest clients. As you can see, we focus on the highly regulated sectors where compliance is a big issue: the medical, automotive, and aviation and defense industries. But we have a bunch of companies in other sectors as well: high-tech and embedded, and finance, and things like that. Lufthansa Systems is also our client, where we have over 5,000 users, but we also provide solutions for small teams of down to 10 people, so it's really scalable depending on what you need. Okay, so first of all, I'd like to clear something up before I move on to anything else, which is the question of risk management and quality assurance and the link between the two. Most people think that QA is a synonym to testing, but actually quality assurance is a much broader term. So it incorporates risk management, testing, and a variety of other practices, processes, and techniques. So risk management, as well as other processes and activities, should be considered a part of assuring the quality of your product. And it's one of the building blocks of adequate quality assurance. A good quote that sums it up is, good risk management, I read this somewhere, good risk management includes a real improvement in software development through organized quality assurance activities. So that includes a lot of things that you can think of as quality assurance, including risk management. But having said that, we've had quite a few webinars in the near past where I've talked about risk management specifically, so I'm not going to focus on that. Rather, the other aspects of quality assurance in today's webinar, mostly testing. But software quality assurance is a concept that should span across the entire life cycle of software development and the entire software development process. And it focuses on improving the process of development of software in order to optimize the end product's quality. It involves the continuous monitoring of the process and making sure that the agreed upon standards and procedures are followed all along the development process. So its aim is to provide assurance to clients, senior management, and other stakeholders that the processes and activities used during the development of your software are designed to maintain the high quality of the end product. Software QA also needs to be unbiased, and the quality assurance team should be given some freedom and authority for the process to work correctly. Now, benefits of QA include greater customer satisfaction, of course, which is a direct result of higher reliability and product quality. So the company's reputation is also, of course, positively affected if you consistently deliver reliable and high quality products. So with good QA, the cost of the overall life cycle of the software is also reduced, um, because it's also performed to ensure that software is conformant to requirements and standards, which is a fundamental stipulation in the development of life critical products. The maintenance cost of the software is also reduced since the software requires less modification afterwards with adequate QA. Of course, the correction and modification of errors that are discovered only after the software is released and implementation can be costly and might affect the reputation of your company. So adequate QA procedures would identify errors sooner before the software gets released, therefore resulting in the overall reduction of the entire lifecycle cost. So if your organization defines a process that is robust and certified by experts, then that will be a guideline and may evolve over time into a mature process if improvements are continuously made to that process. And then that needs to be made official and followed through, of course. So that's another aspect you have to pay attention to. And it's a good idea to enforce these processes in a way that allows you to prove that no one on the development team has strayed from these fixed, well-designed processes. So that's also something to think about. As mentioned before, the quality assurance and testing process should span the entire life cycle of the product and every stage of the process of delivery, production, or maintenance should be covered by QA. The concept of quality assurance isn't to test your software all at once at the end, report the bugs, and then fix those bugs, but is to create a quality product in the first place and then also test the quality product. So in order for QA to work and to result in real process improvement, the entire organizational culture, so to speak, has to be transformed and QA has to become a continuous effort. So, more specifically, regardless of what product you're developing, there are two principles that quality assurance follows, which are fit for purpose and right first time. Fit for purpose means that the product does what it is supposed to do, meaning it is suitable for its intended purpose, and essentially it does the right thing. So the other term, right first time, means, as I mentioned earlier, that all errors should be eliminated. Basically, your product should do that thing right, reliably over extended periods of time. So there are many ways and techniques to achieve this twofold goal, which is why QA is supposed to, again, span the entire life cycle. Now, good quality assurance starts with requirements. The way requirements are captured, phrased, prioritized, and managed greatly affects the quality of the end product. So that means making sure that requirements formulated in a concise, punctual, and easy to understand manner is crucial. And this helps developers as well, since they can understand what is required of them and what functionality is needed. As the life cycle moves on, the next aspect of QA is the use of mature processes, which I mentioned earlier as well, which is essentially about defining the right processes to use in the development of your product and ensuring that those processes are used as planned with no deviations from those fixed processes. It's also becoming important that your development team can prove that they have only used those processes that have been designed with quality in mind, which helps with compliance with standards in industries that we focus on, like the medical, automotive, or avionics embedded systems development, or railway software development and other safety critical areas. Then the development is followed by the testing of your software product, and the QA team has to thoroughly test the product's key functionality to a reasonable depth. What that means I will talk about a little bit later on the next slide. And then with testing completed, QA is still not over, because even after release, bugs and other issues will need to be managed with a QA mindset. Because there's virtually no software that gets released without any single bugs. So users will have to be able to submit those bugs that they discover, and the operations team, or QA and development teams together, will have to treat these bugs to resolve all issues. Now, the term you see here, DevOps, is increasingly used which refers to the close collaboration of development and operations teams in an agile environment, usually. So, but whatever methodology the team is using, the collaboration is important as it helps fix all bugs in a timely manner. Okay, now that I've discussed the mindset and theory of QA, I want to talk about the testing mindset specifically, since obviously testing is one of the key points of quality assurance. So while unit tests and good development practices ensure that you're building your product correctly, QA and testing also tries to make sure that what you're actually building is also correct. So this means that the tester mindset focuses more on the end user and has the end user's um, thoughts or how should I put this, the end user in mind. A good tester mindset also differs from the developer mindset, which is more of building the software according to the rules that they're given, because those rules don't ensure the piece of software actually works perfectly in real life situations. Again, with the end user in mind. So the aim of the testing process is to make sure that the software works as it should, and therefore it rigorously checks all the components of the software. So unless you're using the so-called destructive testing method, where you're specifically attempting to cause the system to fail, this doesn't mean that QA is about trying to make sure that the developer's code doesn't pass. Its goal is to provide valuable information about the software to the rest of the team that they can use to make it better. Again, going back, as I mentioned earlier, almost no software can be completely, which means pretty much nothing ever goes live without bugs. And the objective of QA isn't that at all. It's not to fully test everything and fix every single bug or possible malfunction in the system, because it's almost impossible. But to work together with coding to keep the worst ones out of production and only release working products that fit their intended purposes and can carry out their intended functions reliably over extended periods of time. The reasonable level of quality and reliability differs by industry, of course, going back to compliance and regulatory standards and the purpose of the product itself. So now, depending on how you want to achieve this reasonable level of quality and the depth of testing required, you can simply check if the functionality works as planned, which is black box testing, or you can thoroughly review the code of the software, which is called white box testing. So in short, white box testing tests the internal structures and workings of a program, as opposed to black box testing, where the software is treated as a black box, examining purely the functionality of the software without any regard to the internal implementation. There's also gray box testing, which is a mixture of the two, kind of, where the testers of the software have knowledge of the internal data structures and design tests based on those algorithms, but execute those tests at the user or the black box level. How you achieve quality also depends on what methodology you use for your software development. For example, in Scrum, you would test all of your iterations after they are complete, ensuring that each part of your software is tested separately, and then after integration together as well, of course, when the entire product is complete, depending on how small your iterations are. And then for the waterfall and V model, everything is tested at the end, which allows for bigger risk of having to redo large parts or the entire software altogether. So because of this concept of continuous integration and continuous delivery in Agile, or which comes from the Agile approach to quality assurance, and quality assurance being more and more regarded as a mindset of delivering quality products by assuring the quality of your software during its entire life cycle, requirements-based testing is gaining more and more importance in several areas, including automotive and medical development. This type of testing aims to make sure that all requirements are covered by testing activities, and in this way, requirements management becomes a part of QA if you define your requirements with testing already in mind. I talked about this a little bit earlier as well. And if your requirements are designed in a way that they can be verified by test cases, it will be easier to follow adequate quality assurance practices and it will save you valuable time in the long run. I mentioned test cases, and a good definition for that is a set of conditions or variables under which a tester will determine whether a system under test satisfies requirements or works correctly. But of course, you can't really document test cases and test executions on pen and paper, and this is why we have QA and testing and ALM tools to help you achieve quality. Which brings me to my next slide. So all of this is much easier if you document, trace, and then test everything in one place in like an ALM solution with a QA and testing module. Ideally, you will also need a way to define and enforce these processes, and a holistic ALM solution can make your life much easier, ensuring higher product quality and that mature QA processes are implemented along with gapless traceability. And codeBeamer A11, which you can see 2 screenshots of on the screen here, is one of those tools. Its QA and test management feature set is a fully integrated part of the ALM system, which supports collaborative and consistent testing. Test management is integrated with bug management, and in case of a failure at test execution, bugs can be reported automatically. And codeBeamer also provides end-to-end traceability by associating tests with requirements, code, and releases. The test coverage browser, which you can see on the right-hand side, can be used to visualize, filter, and analyze the coverage of requirements with test cases. It supports the implementation of requirements management, best practices, and offers specific features for requirements-based testing. Also, codeBeamer is integrated out of the box with Jira, Bugzilla, Mantis, Microsoft Office, Jenkins, JUnit, JMeter, Selenium, HPQC, and BMW QC, which further supports QA processes and can be extended with a number of custom solutions via our REST API. Okay, before I get into the demo, let me ask you 2 quick questions. If you could answer the poll on the screen, what are you searching a tool for? That would be greatly appreciated. Okay, thank you very much. Most of you are searching for entire development lifecycle. And one more quick one. Out of these 4, if you see the type of methodology that you're using, please select the one that you're using for your development processes. All right, I see most of you are using waterfall and vModel. Thank you for your answers. Okay, and then let me jump into codeBeamer. What you see here, this is the codeBeamer platform. You can manage projects, so every tile that you see here is actually a project that I'm a member of and that I'm working on. And if I go into my infant medical template, for example, you can see I've opened up one of these projects now. Each project has a wiki homepage where you can define processes and everybody can stay up to date on what the process is for that specific project and what they should be doing. It's sort of a knowledge base for everybody working on that project. Then in projects, we have trackers, which are the centerpiece of codeBeamer, and they're differentiated into work items where you do your everyday work. These are kind of like folders for all of your different types of work items, and they all come together into config items like releases and test cases and things like that. And the way we have it set up here is we have requirements-based testing, like I said. So requirements have to be verified by test cases, and then you can also enforce these processes with workflows. Each tracker, so each folder, so to speak, has its own workflow, and workflows can also be chained together. I'll be showing you what one of those looks like in a minute. You can have, these are all test case folders in this template, and these are all requirements folders. So you can have several types of trackers in one project. And this is also completely configurable. It's one of our mostly configured projects, so that's why I'm using this. So you can see, hopefully it's not too clustered, but you can see everything that most of everything that we can support. Okay, so we have test cases which verify requirements. So that provides the traceability. And then test cases can be grouped into test sets. And then entire test sets can be executed and will be saved in the test runs. But also, of course, every single test case can be executed separately as well. And that's the manual testing. I'm going to be showing you a little bit what manual testing looks like. And then I'm going to get into our Jenkins integration, which shows you automated testing. So test cases grouped into test sets, those can be executed and they verify requirements. Also, each test case has to have a test configuration, which is kind of like an environment that you're running it in. So once you execute a test run, that you have to choose which test configuration will be chosen. So that can be anything from the type of hardware or software you're testing it on, or what type of operating system you're testing your hardware on, and so on and so forth. Okay, if I go into my custom requirements, for example, I can go directly from each tracker into my traceability browser or my test coverage browser. In the traceability browser, I can see the traceability through the relationship of all of my trackers. And in the test coverage browser, I can see the coverage of my requirements, along with all the test cases and all the test executions related to those test cases. So if I go into the test traceability browser, I start from custom requirements and I can start adding all the trackers that I want to see the relationship between. So I'm going to add system requirements, and then I'm going to add software requirements. And as you can see, I'm just adding different columns. And down here I can see there's more information. It's more populated. I can see custom requirements, related system requirements, software requirements. And then I'm going to add all the test cases that are related or verify those software requirements. And as you can see down here, I can provide the traceability. And this can be drilled down from your custom requirements all the way down to the source code. But since we're talking about test cases, I'm showing you that here now. Let's see one of these test cases that has already been accepted. Let's take this one. It's been accepted. And I see it already has, no, it doesn't, it hasn't been executed yet. So I can run a test. I can run a test execution on this. I can click on new test run. And then down here, as you can see, I have to choose a test configuration. It's marked with a red asterisk, which means it's required. It's a required field. I'm just going to choose one of them. It doesn't really matter. This could be anything really, like Microsoft, Windows, or whatever. I'm going to click on save, and then in here I can, if I select the test run I've just created, I can actually execute it. So if I click on run, I have my test steps predefined for my test case, and now I have to go through all of my test steps. I see the action that's been defined, the expected result, and then the actual result. So what I'm testing, what I'm expected will happen, what I'm expecting to happen, and what the actual result was. And then you can add screenshots and everything. And I think this is a critical step. Okay, so I'm going to fail, pass some steps, and then fail step. And after I've run through everything, it tells me all tests has failed, but I haven't reported any bugs yet, so I may want to report a bug. And I can click on this link right away from here, from my test execution. Of course, I can choose which tracker I want it to be. Problem reports, anomaly. I'm going to say this is an anomaly. but it could just be a simple bug as well. I'm going to click on next, and now I can add all the relevant information for this bug. I can assign priority, severity. I can assign it to one of my releases, 1.0 for example, or 1.1. I can assign it to my developers, see who is working on these. I'm going to assign it to my colleague. I can add story points, or however you have it set up, man hours or anything that you need. You don't have to work in an agile way. And then where it was detected in, that's also auto-populated. What you're using right now, you can assign it to teams and things like that. And then the summary is going to be bug 4, and then the test case that you're running, and then this description is also auto-populated with all the relevant information. What configuration it was detected in, what release, the test steps and their results, and then this will be assigned to my colleague. I can save it, and now I see that it has failed. It's completed, but it failed. Okay, and since this was a software requirement test case, let me see my coverage for my software requirements. If I open this up, I can see all of my software requirements, all the related test cases. As you can see here, this is a requirement with the light bulb. The flag indicates that this is a test case, and if I scroll down, this play button indicates that that was a test run. And I can see the results, the coverage, incomplete or not run yet, and then over up here I can see a statistical overview of all my software requirements. I can also filter these results. So if I want to see only those that have not been covered, for example, I can filter for that, and then I can export this to Office. And then I get a document with one click where I can see anything, however I filtered it, but in this case, all the requirements with live links and their statuses that have not been covered with test cases. Traceability browser, just as easy as well. You can export it to Office just as simply. Okay, I just want to mention risk management is also similar. So we have requirements-based risk management, and that means risks are related to requirements. And let me show you real quick, let me show you a workflow, how you can enforce these processes, for example. We have a strong workflow set up for the software requirements, so I'm going to show you what that looks like. It's not import, but customize. In the state transitions, you can set up the states, and then you can see the diagram at the bottom here, how that's set up. And then, like I said, you can chain workflows together. In this case, if there's a software requirement whose safety level is set to high, so it's a high safety requirement, then that will trigger this workflow. And as soon as the requirement is set into the draft status, then it will automatically create a risk and a test case related to that requirement. And it cannot be accepted until you verify and run the test case and mitigate the risk related to that requirement. This is also completely configurable. This is you can also set it up in a way that it can only be accepted if both requirements engineers and quality assurance engineers accept the requirement, for example, and they have to sign their e-signatures. And it's really a strong workflow, so you can set it up however you need to. Okay, and then real quick, I want to show you automated testing through our Jenkins integration. This is another project we have it set up. It's a bit cleaner, so I'm going to be showing it here. It has a lot less trackers and a lot less information. Again, test cases are grouped into test sets with test configurations, and then test runs are saved here. In the test configurations, this is another way that you can set up the environment. You can have manual tests and automated tests, for example, and that way you can have everything in one place for your unit tests as well as your manual testing, and you can view both types side by side in the coverage browser and the results together. So the way you set it up in Jenkins is, this is our plugin. It's the codeBeamer X Unit import plugin. And all you have to do basically is in the plugin, set up the URI, your username and password, and then the tracker IDs. These are all coming from codeBeamer. You just have to copy and paste these into here. You have to set up. These are this required ones, of course. The test configuration item ID, which in this case is going to be automated because these are automated tests 71994, 71994, this test set tracker ID, the test case tracker ID. I have a folder where I want to save all of my automated tests in so they can be distinguished from manual testing, and that's 71997, and then the test run tracker. Optionally, you can set up a bug tracker ID as well, so if something fails, then that will automatically create a bug. And also, if you are you don't have your requirements determined in codeBeamer yet, then this is also an option. You can set this up a requirement tracker ID, and then you can just execute these builds, and then that will create a requirement that the test case, the automated test case, will be linked to automatically with the same name. So that will create a requirement as well as the related test case, and it will also link them together. Okay, so I'm gonna save this real quick and I'm gonna run a build. If I go back into test cases, as you can see, the way we have it set up is manual tests and automated tests have separate folders. And then I'm gonna click on build now. And this is gonna take a few minutes probably, so I might not wait for it to end because it's a pretty big build. But if I refresh the page, you can see it's already creating these automated test cases. And then optionally, if you already have your requirements set up in codeBeamer and then you start testing with automated tests, you can go into system requirements where we have it set up. And then I have another folder with automated requirements. And then through the test case library, you can actually just start dragging and dropping your newly created automated tests and assigning them to requirements. So let's say I'm gonna verify this with this. As you can see, as soon as I drag and drop it onto the hierarchy, it asks if I want to verify a requirement with the original test case or make a copy of the test cases and verify the requirement with the copies. I'm just going to choose verify requirement with the original test case. Also, in both cases, suspected links are propagated. So if something changes with the requirement or the test case, then you have to go back and make sure it's going to be that it's not a suspected link. Okay, so I'm going to drag and drop and verify this one with this. And I think the build is still running, so that's why it's going to be, might be a little slower. Yeah, that build's still running, but I can still view the coverage browser since I added it here, and then you can see your requirements with all the test cases, and then as well as the manual tested requirements. And this can all be seen in one place. All right, well, that's everything. I think I've covered it all. Now, before you ask your questions, I have two more quick questions for you. If everybody could please answer them. Would you like to receive further information about codeBeamer ALM? Okay. All right, thanks for your answers. And then one last one, and then you can ask your questions. How do you feel about today's webinar? 1 through 5. Okay. All right, thank you very much for your answers. Okay, and now you can If you have any input or have any questions, you can type them into the chat box. I'll be available and try to answer everything. Okay, Václav asks, is the new version of codeBeamer implemented in heritage of relations, for example, by inheriting requirements? I want to inherit the test cases as well. Um, what type of inheritance are you talking about exactly? Could you clarify that, please? If you reuse, if you reuse a requirement through the requirements library? Okay. Um, so if you copy a requirement, for example, from the requirements library, does the test case get inherited? I believe no, you're going to have to reuse the test case and then verify a copy with that requirement. So you'll first have to copy the requirement, reuse it, and then since it's a different requirement, you're going to have to copy the test case that verified the original onto the new one as well. And that will create the relationship. Yeah, so it doesn't do it automatically. All right, any other questions? Okay, Aman asks, can requirements also be defined for post-release tasks? I'm thinking, for example, of bug reports from users, given that software QA covers the entire lifecycle, is a requirement about user feedback something sensible? So you mean for DevOps or like for after release, um, for your users, can you have feedbacks coming in from them? And where they can, so do we have a platform where they can report bugs or feedback or change requests and things like that? Is that what you're asking? Yes, we do. It's called the service desk, and you can configure that. And then it's a platform. Hold on, maybe I can show you. Yeah, if you can see my screen, this is what it looks like. It's the service desk, and then all your users can submit requests and they will automatically be they can report a bug, they can add feedback, configuration changebacks, or configuration changes, and then another type of this is also configurable, so you can add whatever type you need. And then if someone adds a bug, then that will all automatically be added into your bugs tracker, and then you can work on that even after you've released your product, of course. So this is exactly what it's for, and then they can track their requests, and if you finish them, for example, then they will also be notified that this bug has been closed, so on and so forth. Yes, it is supported natively, exactly. All right, great. Any more questions? Feel free to ask about anything else if you want. All right, no problem. Okay, does anybody else have any questions? Okay, I'm gonna wait 1 more minute since a bunch of you are still online. But if nobody has any other questions, then thank you for your attention. And make sure you join us next week, same time, same place, about business intelligence with visual data analytics, reporting and dashboards. It's also, you can create those for quality assurance, so you can create testing dashboards, requirements dashboards, or for SAFE, we've actually got a new template, SAFE 4.0. I saw one of you was looking for that in one of the polls. If you're still online, I'm going to be showing you creating dashboards for the different types of levels of SAFE, portfolio, program, and team level, and all types of reporting and charts and visual data analytics. Okay, so no more questions. Thanks again for your attention, and have a nice day, everybody. Bye-bye.